Look around you again. The air moving, the rain falling, plants growing. Nothing here is static. Everything moves. In nature, balance isn't maintained by stillness, it's maintained by cycles. These movements of matter between air, water, land, and life are called biogeochemical cycles. Let's start with the most talked about one, the carbon cycle. Carbon moves through the atmosphere as carbon dioxide. Plants absorb it during photosynthesis. Animals eat plants. Carbon returns to the air through breathing, decay, and burning. For thousands of years, this cycle stayed roughly balanced. Then humans stepped in. Burning fossil fuels releases carbon faster than ecosystems can absorb it. Deforestation removes natural carbon sinks. The result is accumulation, not circulation. That's why carbon is now tied to climate risk, energy policy, carbon markets, and global economics. Now let's move to the nitrogen cycle. Nitrogen makes up most of the air, but plants can't use it directly. Special bacteria convert nitrogen into usable forms in soil. Plants absorb it. Animals eat plants. Nitrogen eventually returns to the atmosphere. This cycle controls food production. When humans add too much nitrogen through fertilizers, the cycle breaks. Rivers become polluted, lakes lose oxygen, dead zones appear. Food security rises in the short term, but ecosystem damage grows in the long term. Now the most familiar one, the water cycle. Water evaporates, forms clouds, falls as rain, moves through rivers, soil, and groundwater. This cycle controls drinking water, agriculture, weather, and industry. When land use changes or climate warms, this cycle shifts. Rainfall patterns change, droughts intensify, floods become more frequent. Now zoom out. These cycles don't operate separately. They are linked. Carbon affects climate, climate affects water, water affects soil and nitrogen. Disrupt one, and the others respond. This system's view was formally recognized by Vladimir Vernadsky, who showed that life, Earth's chemistry, and physical processes form a single connected system. His work laid the foundation for understanding Earth as a dynamic, living planet, rather than a collection of isolated parts. Today, these cycles sit at the center of global decision-making. Organizations like the United Nations, through scientific bodies such as the United Nations Environment Program, and climate assessment panels, track carbon flows, nitrogen pollution, and water stress worldwide. Their data informs climate agreements, agricultural policy, water management, and long-term economic planning. This isn't academic monitoring, it's risk management. When cycles stay balanced, societies remain stable. When cycles break, costs rise in food, health, infrastructure, and conflict. Before we end, zoom out one last time. Biogeochemical cycles reveal a hard truth. Nature doesn't lose matter, it redistributes it. The real question is not whether change happens, but whether systems can absorb it. In the next episode, we'll focus on climate change, where we'll see how disturbed cycles translate into rising temperatures, extreme events, and global risk. This series is part of the Learning Studio, where complex systems are explained step by step, using logic, evidence, and real-world relevance. This isn't about memorizing cycles. This is about understanding how the planet actually operates.